Okay, so here comes page 3 and 4 for you. So for number 7, we have right triangle ABC. Angle C is 90. And the sine of A, remember the sine of A is opposite over the hypotenuse is 3/5. So from A, the opposite side is 3, the hypotenuse is 5, and we want to do the tangent of B. So for tangent of B, it's the opposite. Remember, tangent of B is equal to the opposite leg over the adjacent leg. The opposite leg is this one, but we don't have a value there. So we have to get it. So in order to get it, we got to use Pythagorean Theorem here. So a squared plus b squared equals c squared, right? A squared plus 3 squared is equal to 5 squared. So a squared plus 9 is equal to 25. Subtract 9, we're going to get a squared is equal to 16, and then a is equal to 4. So now I know that the tangent of B is equal to the opposite leg, which is 4, over the adjacent leg, which is 3. And that's it. So at the test tomorrow, if it asks you for the ratio, it's just a fraction, okay? Difference than just find the length of the side or find the length of the angle. The sine of an angle is just the ratio of the sides. Same thing, okay? Number 8, it's asking me to find the value of x. I know that it's a right triangle, and it's saying the sine of A is equal to this, and the cosine of B is equal to this. Our battery's dying here. All right, so in this case, we know that the sine of A is equal to the cosine of B, so we're just gonna set these two things equal. So 3x plus 10 equals 2x plus 35. And then we can subtract 2x, subtract 10, and we're gonna get x is equal to 25, okay? Now, the other option that they come up with questions is they say the cosine of 3x plus 30. So here they're telling us what the sine of A is. So this is the value of my ratio, right? And then we set those equal to each other. Here, the cosine of x is equal to the sine, x plus 30 is equal to the sine of x. These are the angle measures. So these two angles add to 90. So 2x plus 30 is equal to 90. Use a little subtraction property equality. 2x is equal to 60, and then x is going to equal 30. Okay, same concept here. If the cosine of 2x plus 25 equals the sine of 35, we know that these two angles add together. They're not equal, they add together to equal 90. Okay, they're complementary. So 2x plus 60 is equal to 90. 2x is going to equal 30, because we're going to take 60 away from both sides. And then we divide by 2 to get x is equal to 15. How did we arrive at our answer? And then all we need to say again, remember, if cosine of A is equal to the sine of B, then the measure of angle A plus the measure of angle B is equal to 90. Okay? So number 11, Chris likes to take long, relaxing walks. Maybe a minute, okay? With his dog Spot. And he decides to walk to the lighthouse, as shown below. So Chris starts at point A, here's point C, okay? And the angle of elevation to the top of the lighthouse from Chris is approximately 35 degrees. Remember, Chris is 6 feet tall, so there's this 6 feet on here from his eye light, all right? And then he moves another 20 feet up to spot C. So there's Chris number 2, okay, spot. And then this distance is 20 feet across. And we know that the angle of elevation started at 35 degrees and it's now 45 degrees. So what we want to know is how far from the nearest tenth of the foot is the lighthouse. All right, so remember, we're going to need to figure out this height of the triangle here, right? You can call it x if you want. And then to get the entire height, I'm going to have to do that plus another 6 feet. All right, so the first thing we need to do is use this small triangle to get the side in one of these two right triangles. We'll focus in on this guy. We want to use this triangle to figure out the hypotenuse, the shared side between them, okay? And then once we have this side, we'll be able to identify what x is. So in this obtuse triangle over here, all right, this triangle ACB we know that angle A is 35. Okay, this is 45. So 180 minus 45 is 135. That's what this is. And then angle B this is 170. So 180 minus 170 is 10 degrees. Okay, and we know the distance from A to C is 20 feet. So if we want to figure out this, we're going to have to use law of sines. We can't use SOHCAHTOA because it's not a right triangle, and I have two sides and two angles essentially across each other. But I'm trying to figure out what this side, we'll call it A, is. So I'm going to do the sine of A over A, and here I have B, so it's equal to the sine of B over B. So angle A is 35, sine of 35 over A, because I'm looking for it, is equal to the sine of 10 over 20. And then we just cross multiply this out. So 20 times the sine of 35 is equal to A times the sine of 10 divided by the sine of 10. Okay, and A is going to equal this really not nice number. So it's 20 sine 35 over the sine of 10. So it's that number, 66.0. Now I don't want to round this, so I'm going to write that whole thing down. So it's 66.06190100297 is equal to A. So now I need to do what this side is. Okay, so I can either use my 45, 45, 90 right triangle rules, or I can just do some SOHCAHTOA. I'm going to do SOHCAHTOA for here just for some extra practice. So this is A. We know what that is. That's that number. We're just going to use A to represent that number right now. And I'm looking for this. There's my angle, so that's the opposite and the hypotenuse. So I'm going to do the sine of the 45-degree angle is equal to the opposite, which is x, over that A value, that crazy number right there. And so now, when I cross multiply, I get A times the sine of 45 is equal to x. And I'm just going to take my answer that we just got and multiply it times the sine of 45. And I end up with this. Okay? And so it does say nearest tenth, and I'm just going to add on to that. So this is 46.71281811962, and then the whole height, okay, is equal to x plus 6. And so if I just add 6 to this and round it, it's 52.7. And so that's the height of the lighthouse. So essentially, we're using the small triangle to get the side that's common to both the right triangle and the obtuse triangle, and then we're doing some SOHCAHTOA off of that. All right, so number 12. Surveyor has to calculate the area of a triangular piece of land. Lengths CE and DE cannot be measured because they go through a swamp. A, B, D, E, A are straight paths. We have the intersect at point C, and they give you the lengths 15, 10, and 12, and DC is 9. So we want to find the measure of angle ACB. So we need this angle down here. Okay. So it's not a right triangle because we don't have any right angles. Okay, not that we know of, so we can't treat it as one. And now we have three sides and an angle. So this is a case where we're going to do the law of cosines. Okay. So we're trying to find angle C. So we're going to start with side C. So C squared is equal to A squared plus B squared minus 2AB times the cosine of C. Remember, I'm going to give you that formula tomorrow. Okay, and then you plug in. So 15 squared is equal to 12 squared plus 10 squared minus 2 times 12 times 10 times the cosine of C, which we don't know. Okay, now remember we talked about this. I can multiply together this sum. I can multiply together these product of numbers here, because remember, this is a variable attached. This is like an x. And I can do this, okay? I cannot combine these two things together because this has a variable attached. All right, so 15 squared is 225. I'm going to combine 10 squared and 12 squared, and that's 244. And then I'm going to combine 2 times 10 times 12, which is 204. So minus 240 times the cosine of c. So the next thing I'm going to do is get rid of the 244. So I'm basically solving for c, right? So I'm going to get a cosine by itself. So move this first. Which is negative 19 is equal to negative 240 cosine of c. Okay, then we're going to divide by the negative 240. All right, and then c is going to equal, remember, we're going to do the cosine inverse of that fraction. So cosine of c, and we do the cosine inverse, so let's cancel out, negative 19 over negative 240. Okay, so trig, all right, we're going to go over to cosine inverse, and then negative 19 divided by negative 240. Double check, make sure that's what it says, and we get 85 point. We want to go to the nearest degree. So 85 point, the next number is a 4, so it stays the same. So C is just equal to 85 degrees. Okay. Angle DCE below is vertical, so it's equal. So angle DCE is equal to 85 as well. And then for B, the surveyor measures the angle, size of angle CDE to be twice the measure of angle DEC. So angle D and C, right? This is 2 times the measure of this. So I need to know this first. So DEC is essentially x, and angle D is 2x. I know that this is 85, so I need to figure out the length of DEC. So this is just a quick equation equal to 180. So it's 85 plus 2x plus x. Move the 85 over. So we get 95 is equal to 3x, and then we just divide by 3. And we get a not nice number, but it's essentially 31.6 repeating as x. Okay, and then we want to find the length of DE. So we already know the measure of x, right? We have 9, 85, and we're looking for this. So that's going to be a law of sines. So it's the sine of E over E, and then the sine of C over C. So this is the sine of E, which is 31.6 repeating. I'm just going to use the answer that we got here and just bring that down, okay? Over E is equal to the sine of C, which is 85, over side C. Oh, by the way, E is 9, so 9. And then just cross multiply. So 9 times the sine of 85 is equal to C times the sine of 31.6 repeating, or you can leave it as 95 over 3. Oh, let's move it so you can see it, right? 95 over 3. And then we just divide by 31.6 repeating, sine of 31.6 repeating, sorry. Or 95 over 3. And we type it in the calculator. So I just double checked to make sure that answer worked earlier. So it's going to be 9 sine of 85 outside the parentheses divided by sine, and we'll just go up till we get there and bring it down. Oh, can't do that. Okay, there's a problem. So I want to undo it. So Control Z will undo. I need to move my cursor where I want that to copy to. So it's got to go right there. So now when I go up, I think I know what the problem is. I keep hitting up. All right, I'm guessing you guys have this as your last step. So let's get this back. There's 31.6 repeating. Okay, if that's the last answer you have, this will work out perfectly. Otherwise, I would just use that fraction. So we're going to do 9. Try to do this again. And then sign, and we'll just do control for answer. All right. Otherwise, I would just do 9 sine of 85, and then divided by, because it's bringing it down in that spot, because I keep pressing up, I move up there. I would just use the fraction. We got what, 95 over 3, and we'll get the same answer. Okay, so find the length of DE, and it's going to be that 17.07 number. This should be rounded. It will say what to round to in the test. Okay, the next question is kind of weird. So a boat race around a triangular course. AB is 700, BC is 900, and angle at ABC is 110. The race starts at point A. Calculate the total length of the course to the nearest meter. So what I need is to figure out this length over here. So this is a law of cosines because it's 3 sides in an angle. So we are looking for B. We're going to start with B squared is equal to A squared plus C squared minus 2AC times the cosine of B. You will have a cosines question on there tomorrow. Just be aware. 3 sides in an angle. And then all we're going to do is plug in. So it's 700 squared plus 900 squared minus 2 times 700 times 900 times the cosine of 110. And then all we're going to do is take the square root of all this junk over here, okay, both sides. All right, so grab a calculator. We're going to do square root 700 squared plus 900 squared. All right, minus 2 times 700 times 900 times the cosine of 110. Okay, double check. 700. Hit enter, make sure it looks the same, and we get our answer. So it says nearest meter, which would be 1,316. Okay. B, the race is filmed from helicopter H, which is flying vertically on above point A. All right, this is the weird thing. Here's my helicopter. When you connect these points together, because it's flying vertically above this point, all right, the angle of elevation of H from B is basically someone who's standing here and then looks from B to H. So this is my angle of elevation down here, which is 15 degrees. I know it's worded kind of weird. This is an IB question. And this distance here, these two lines are perpendicular. So we have a right triangle. We have this 15-degree angle. We know this is 700. We want to calculate the distance the helicopter is, this AA over here. So this is just a simple question where, we say simple, but where we have a right triangle with a hypotenuse of 700 and an angle of 15, and we're looking for this. So it's just a SOHCAHTOA question here, guys. Okay, we have the adjacent, we have the hypotenuse, so we're just going to do the cosine of 15 is equal to adjacent x over hypotenuse 700, and then we just cross multiply. 700 times the cosine of 15 is equal to x. 700 cosine 15, and we're going to get, let's do nearest 10th. So 676 and then 0.1. All right. And then what's the maximum possible distance? Basically, we just want to figure out how to get from H to C. That's the distance we want to know. All right. Now we just figured out this. We know this side. Okay. So we want to figure out this guy. And because this is flying vertically above this is also a right angle. So essentially, we just need to use Pythagorean Theorem here. So we're just going to do the old A squared plus B squared is equal to C squared. I'm going to do that over here for letter C. All right, so A is our answer here, 676.1 squared plus B squared is that number we got earlier, 13.8. 1,316 squared is equal to c squared. We can square out these numbers individually if you'd like. Okay, and then we're just going to add them together. Oh man, I broke it. So 676.1 squared plus 1316 squared. Hitting too many buttons here. Is that number right there. So that's 2,188,967.21 is equal to c squared, and then we just take the square root. So we square root that answer, and we get. And let's go thousandth here. So if we're going thousandth, 3 zeros and 1,000, so the 5, and we're going to round that up. So that's a 6. So 1,479.516, and that would be meters. All right, guys. Thanks for sticking along here. See you guys tomorrow, and we'll go from there.